Good evening. This is last video of Diwali work. That is day 6, part 2. Now in this we have a cylindrical chimney 22-meter high of uniform section. Uniform circular section is having 4-meter external diameter, 2-meter internal diameter. The intensity of horizontal wind pressure is 1.5 kilonewton per meter square. Find the maximum and minimum pressure intensities. Actually, if we will draw this diagram, then we have diagram in this fashion. And then this value is given 1.5. Kilonewton per meter square. So now we have to find area. So we have given data A equal to pi by 4 in bracket 4 square minus 2 square, and we have this area 9.42 meters square. We have pi by 64 d to the power 4 minus d to the power 4. We have this value 11.78 meters square. Then we have P, which is weight of chimney, and that is equal to unit weight of machinery into area into length. That is gamma into volume. So this is given 20 into 9.42 into 22. And we have this weight equal to 4144.8 kilonewtons. Then we have M. Now we know M is equal to, so we have total load will act overhead. I will say PH, and this will be at H by 2. And H we have 22, so H by 2 will be 11 meter. Then we have PH, horizontal force due to wind, that is equal to wind intensity multiplied by projected area. So wind intensity is given 1.5 into projected area 4 into height is 22, and this is into 2 by 3. And then M we have PH into H by 2. So moment about base. So PH into H by 2. H by 2 is 11. So we have PH 1.5 into 4 into 22 into 2 by 3. And that is into 11, which is H by 2. And we have M 968 kilonewton meter. And then we have to find sigma D, which is equal to P by A. That is W by A. W is 4144.8. And area we have 9.42. And we have this value 440 kilonewton per meter square. Sigma B we have M by I into Y. M we have 968. I we have 11.78 into Y by 2. So 4 by 2. And then we have this value 164.35 kilonewton per meter square. And then we have sigma max. So we have on one side sigma D plus sigma B, and sigma mean we have on another side sigma D minus sigma B. And we have this will be 440 plus 164.35, and we have this value 648.34 604.35, sorry, 604.35 kilonewton per meter square, and 440 minus 164.35, which is equal to 275.65 kilonewton per meter square. So we have these values, maximum and minimum. This 2 by 3 that already we know. This is pressure coefficient for circular section. For rectangular and square, we have that value as 1. Then we have RCC rectangular footing in plan. So we have this value as 2 meters. This value we have 2.5 meters. And first load we have given 100 kilonewton, 0.2 meter and 0.3 meter, that is from x-x axis and from y-y axis respectively. Then we have 110 kilonewton, which is on y-y axis, and 120 that is on x-x axis. So we are interested with values for corners. So we have corners. So this is A, B, C, and D. So now we have total load. P, we have to consider all loads. That is 100 plus 110 plus 120. And we have this value, that is 330 kilonewtons. Area we have 2 into 2.5, 5 meters square. And then Ixx and Iyy. So Ixx. So we have for Ixx, B is 2.5 into 2 cube by 12. And that is equal to 1.67 meter to the power 4. And then we have Iyy, 2 into 2.5 cube by 12. And we have this value, 2.6 meter to the power 4. And then we have to find out sigma A. So we have P by A. P is 330. And by A we have 5. So this is 66 kilonewton per meter square. Now we have mx, moment about axis. And that in that case, we have moment due to this 100 and moment due to 110. So we have more due to 110. So we have compression on C and D due to mx. So we have 110 into 0.25 minus, because one will be clockwise, another will be anti-clockwise, minus 100 into 0.2. And we have this value, 7.5 kilonewton meter. Then if we will go my, then my we are due to 120 larger than 100. So we have 120 into 0.4 minus 100 into 0.3, and we have this value 18 kilonewton meter. And now you can see we have sigma Bx is mx upon ix into yx. So m we have 7.5 into 5 kilonewton meter. I we have 1.67. And now about xx means we have d as 2 meter, and therefore we have y as 1 meter. And this value is 4.49 kilonewton per meter square. And sigma by we have, this will be xx. So we have my upon iyy into yy. And we have this value 18 divided by 2.6 multiplied by 1.25, which is equal to 8.65 kilonewton per meter square. And then we can have all corners. So let us, we will write for all corners. So we have sigma A. Now then we have sigma B. Then we have sigma C. And then sigma D. Now due to P, we have all plus. So 66, 66, 66, 66. Due to mx, we have bending moment on this side. So C and D we have plus due to mx. So mx we have C and D plus. So 7.5, sorry, 4.49 sigma bx and 4.49. So these two will be minus. This type of question was asked once in the examination. Now we are on this side 120 kilonewton greater than 100. Moment developed is greater than this 100. And therefore B and C we have plus. So sigma by B and C plus. So plus 8.65 plus 8.65 minus 8.65 and then minus 8.65. And then we have this value. Sigma A we got 52.86 kilonewton per meter square. Sigma B we have 70.16 kilonewton per meter square. Sigma C we have 79.13 kilonewton per meter square, and sigma D we have 61.84 kilonewton per meter square. Likewise, we have to solve problem when we have number of loads over here. Now we will switch over to the last problem of this, a tapering chimney. So now tapering means we have diameter are different. So we have given 3.5 at top bottom and 2 at top. So we are being like this. So in such problem, you have change only in the projected area, remaining things are same. So we have to consider projected area. This is 2 meter. This is 3.5 meter. So we have, now we will go with first, P is given 5000 kilonewton. We have to find at base. So we have area at base. Internal diameter is given 1.5. So we have pi by 4 in bracket 3.5 square minus 1.5 square. We have this area 7.12 meter square. Sorry, area 7.85. So we have this as 7.85 meter square. Then we have I, pi by 64, D4 minus D4. You have to write formulas in the examination equal to 7.12 meter to the power 4, and then you will get sigma A is P by A. P is 5000. A is 7.85, and you have this value. P by A, we have 636.94 kilonewton per meter square. Now we are interested with pH. pH is gamma. Gamma is given 1.2. This is meter square actually. So we have 1.2 into, we have average 3.5 plus 2 upon 2 and multiply by height we have same, that is 40. And from this we will get value of pH, and I got this value of pH equal to 132 kilonewton. Now here it is not H by 2, we have to find CG, CG of trapezoid, trapezium, sorry, trapezium, that is equal to, if I will say this as A, this as B, then we have CG as A plus 2B upon A plus B into H by 3. And we will get it as A we have 3.5, B we have 2 into 2, divide by A plus B, 2 plus 2, 3.5 plus 2 into H by 3, that is 40 by 3. And I got this value 18.18 meter. And then we have M equal to pH into CG. So 132 multiplied by 18.18. We have this value of M 2399.76 kilonewton meter. And then we will get sigma B, M by I into Y. M is 2399.76. I is 7.12. And we have this value 589.83 kilonewton per meter square. And we have sigma max, sigma A plus sigma B, sigma A 636.94, sigma B 589.83, and we have this value 1226.77 kilonewton per meter square. And sigma mean, we have sigma A minus sigma B. So 636.94 minus 589.83, which is equal to 47.11 kilonewton per meter square. So likewise, we have to solve the problems. Now we will stop here only. Thank you.